Hey, hi everyone. Good morning.
Good morning, sir.
Yeah, good morning, Shrikant.
Good morning. All right, so get started. Okay, so today we are going to talk about unsupervised learning. Can anybody tell me what is unsupervised learning? So we did discuss about this, right, multiple times. What do you mean by unsupervised learning? Okay, Harish, Saurabh.
Where the input and output variables are not defined.
Only the output variable is not different. The input variable would be there, right? So you need to pass input variables to the algorithm. But here we are not supervising the algorithm saying that this if this is the input, then this should be the output. So here we are just passing the input features, and the algorithm will try to identify the patterns and the different homogeneous. It will try to find out the homogeneous groups, okay, from the data. So when we talk about unsupervised learning, the most general kind of technique which we discuss would be the clustering. So, as a name suggests, clustering is all about to create a clusters. Can anybody tell me where we discuss about clustering? In one of the classes, we did discuss about clustering. So, anybody remembers where we discuss about clustering? So we talked about clustering in sampling class, if you remember, right? So in when we collect the samples, we there is a technique known as clustering, right? So what it clustering does is we use this unsupervised learning to come up with the different clusters in the original data, and from each of the clusters we pick up certain observations to generate the samples. So clustering is all about when you have huge amount of data which is not labeled. As I mentioned yesterday, uh, this labeling task is quite tedious and it's manual. It's more laborious and mundane kind of a task. Generally, people will not prefer to do this kind of task, and in any company also, there wouldn't be any team who can do the labeling. So generally, for doing the labeling, you need to have a team who has some functional understanding and can do this kind of a mundane job. Okay, so in this kind of situation, to overcome this kind of a challenge, people generally go with the clustering technique, and with this clustering technique, what happens is it finds some homogeneous groups inside the data. Homogeneous groups means observations which are quite similar to each other, uh, that would be grouped under different categories or under different clusters. So that particular technique is known as clustering. So once the cluster has been identified, then the observations will be labeled. For example, this particular observation is belongs to cluster 1. This belongs to cluster 2. This belongs to cluster 1. This belongs to cluster 3. So whatever number of clusters you decide, that many number of clusters it will identify from the data in the data, and the observations will be grouped inside that particular cluster. Now later what you can do is uh, you go and analyze all the observations in each of those clusters and then properly label with certain names, certain categories. For example, this cluster 1 should be, could be like a potential customers. Okay. Or cluster 2 could be non-potential customers or whatever name you want to give, okay, based on their attributes or based on their patterns. So now let's talk about uh, a use case. So here, the customer segmentation. Probably you guys might have heard about customer segmentation, some or the other in scenarios. So customer segmentation is the most generic solution when it comes to customer analytics or marketing analytics. Now, this customer segmentation solution would be used by marketing teams or sales teams or even customer service teams. So now let's suppose a company, any company has millions of customers. Okay, so when you have customers, definitely you need to have continuous interactions or engagements with the customers so that uh, they are with you, okay, and you can generate some revenue from them. So continuous targeting those customers would be important to generate constant revenue. So when you have millions of customers, how would you plan to target? How you strategize your marketing activities? Whom to target? When to target? So that would be that would not be an easy decision. So in marketing, generally, okay, you might have heard about this particular jargon. Uh, Targeting the right customer at the right time with the right product or services or campaigns is a key for success. Okay, and that's how that this marketing activities efficacy increases. So for that, the segmentation plays a very vital role. For any businesses to target, it requires some efforts, it requires some cost, okay, it requires a team, right? So a lot of preparation needs to be done. So any customer, if any company, if they are having millions of customers, they cannot target all of them at once, okay, and in the same way. They need to be a separate strategy for targeting different customers. Now, you might have observed like if everyone uses e-commerce, right, for doing some online shopping. You might have seen that when you purchase something, you will start getting some kind of offers, some kind of campaigns, emailers, and all those things. And those would be most relevant to your preferences or your buying pattern. So somebody is observing your buying pattern. Somebody is observing, what you like, what you dislike, and then accordingly, the right things are being offered to you. So segmentation can be done in multiple ways and it changes from company to company, okay, from domain to domain. So for banking, the customer segmentation is done in a different way. In a different way means the attributes of the customers could be different in the banking scenario. For the e-commerce, the attributes could be different. And for manufacturing, basically the manufacturing companies, they prefer B2B business, right? So there would be a dealers and other businesses who would be buying products from the marketing from the manufacturing companies. So there would be very less people who are like end customers or the end buyers. So there the segmentation could be different. So you need to look out for the right attributes to define a particular customer, whether that customer is a potential customer or it's not a potential customer or it's a mediocre customer. So that kind of a segmentation would be required to target or to plan any kind of marketing activities to sell any products or services to your customers more appropriately. So here, if you see in this particular use case, this is more of a banking scenario. where you have customer IDs, and this is your CRM, let's suppose, customer relationship management. Okay, so it could be there are multiple CRM databases. You have Salesforce, you might have heard about Salesforce. So Salesforce is one of the database. Then you have Microsoft Dynamics. Okay, that is another CRM. So like that, there are multiple databases in the market which capture all these customer data. And in this database, you will find all the information related to the customer transactions, customer engagement, what kind of emails you have sent, at what time, and how they responded. Everything will be there. And if the sales guys they have reached out to those customers, at when they reached out or what they reached out, everything related to customer relationship would be captured in this particular database. Now, if you have given the access to this particular database, now you have to select the right attributes, which can help uh, help you to segment your customers in a better way. Now, for example, in this banking scenario, I've taken the customer ID, I've taken the age of that customer, education, years employed, income, and so on and so forth, right? And this is a defaulted means whether that person in the last 6 months or 1 year has defaulted any of his payments. So it is marked as 0 or 1. Okay, so 1 being defaulted, 0 means not defaulted. Now, based on these attributes of this customer, now what we will do is we will go and run the clustering technique. So now let's suppose you have the data which is scattered all throughout in the n-dimensional space. Now, this particular algorithm will try to find out the homogeneous groups, okay, or the clusters which are in which all the observations are quite similar. Okay, and it will also make sure that other clusters in this particular data is quite heterogeneous in nature. Okay, so heterogeneous means which are different, right? So within the cluster, the observations should be homogeneous. So that means they should follow the similar kind of pattern. And the observations in other clusters should be heterogeneous. They should have some different patterns altogether. So once these kind of clusters have been identified, then I can go and further analyze that. So this cluster one, if I go and analyze, I'll find that they are more of a affluent and middle-aged kind of customers. Okay, so I'll name them as this particular segment, right? Affluent and middle-aged. When I looked at cluster two, I found those are more of a young, educated, and middle income, right? So accordingly, I'll name that particular cluster. Cluster three would be young and low income. So firstly, what did is I just used the algorithm and I tried to identify the clusters. And after that, I analyzed each of those clusters, and then I named a proper category. I have uh, decided to give it to those clusters. Now, with these cluster names, now I can go and label this particular data. So now this customer ID falls in this particular segment. Customer ID 2 falls in this particular segment. So like that, I have labeled all these customers with these three categories. Now my data got labeled. Now what you can do, now you have a labeled data with you. Now you can try some supervised learning algorithm, whatever we have discussed. So it would be a multi-class classification problem. Now you can train the model on top of this labeled data. Now, if any new customer is coming, okay, if you have any new customers data, then you can pass it to that particular model and then you can predict or classify the category of that particular customer. So earlier where I didn't have any labels or any categorization done on my customer data, I used this unsupervised learning and I got some labels around each of those customers. And then I have used a supervised learning model to train my model so that I can predict any new customers who are coming into my database. Okay, so this collection of supervised learning technique and this unsupervised learning technique together is called as semi-supervised learning. So where you use unsupervised learning and label the data and then use the supervised learning to classify a new data. Okay, so now, so that's what the clustering is, a group of objects that are similar to other objects in the cluster and dissimilar to data points in other clusters. So it's just like homogeneous inside the cluster and heterogeneous outside the cluster. Okay, so that is known as clustering. Now, how basically it is done? Okay, so firstly, let's understand the difference between clustering versus classification. In clustering, in classification, primarily, when we call about the label data set means if you have clearly identify what you would like to classify or predict. Okay, so for example, in this given data only, let's suppose I want to predict whether that person will default or not. Okay, so then this defaulted column will become my output column because that is my interest. And I want to train the model which can predict whether the person will default or not. And in the banks, it is again a very important solution. Now, you might have seen that people like recovery agents and even the telecallers, they keep uh, calling someone, if for them for making the payments. So one is like they will remind you for making the payment. And sometimes, they even force you to make the payment. So if the model is predicting that there is a high chance that this person is going to default, then they will keep calling you and they keep reminding you that you have to make the payment, and they will use all the different tactics, so that a customer makes the payment, right? So even it also helps for the banks to understand what could be the size of the NPA, which is non-performing assets. Non-performing assets is a bigger risk for the banks because even if it increases too much, then even it may lead to a bankruptcy. So they monitor every customer, whomever they have provided the loan, or they have given the somebody has taken the policies. They keep following those people, and they will use this model to understand who all customers may default in their payments. And if the model says that somebody is going to default, then they will take the necessary actions. So here also it is very critical, because if somebody is not going to get default actually, but your model is predicting is going to default, just imagine, okay, it's going to again affect the brand value. If I am a genuine customer and I'm regularly paying, and if somebody calls me and harass me and or tells me that, okay, if I am not going to pay, something threatening calls, I get it from the bank, definitely I would not be their customers, okay, that bank's customer. I may uh, go to some other bank. Okay, so again, it may lead to a problem. And this, at the same time, if it is like uh, uh, false negative, then again it's a bigger risk, right? So the bank would lose business. So in this case, if my interest is to predict the default, then this data can be considered as a label data. Okay, because this is something which I would like to predict, and it is also existing in my data. And these are all my input features, and I will go and validate if these input features are relevant or significant to predict the default of any customer. Then I will use this particular data as a label data, and I can use it for my supervised learning model. Okay, so here I will do the modeling. I will use the decision tree because it's a supervised learning algorithm. And then once the model is trained, I can use it for prediction. Now, for example, now the same data, but here I want to classify the customers. But I want to classify it for different purpose. I want to classify it for targeting those customers. I want to classify those customers um, for my marketing campaigns. Okay, so in that case, I do not have any kind of label available in this particular data, right? So it becomes my unlabeled data. Now, if it is unlabeled data and I want to group the customers into homogeneous clusters, then I will use a unsupervised learning, here the clustering technique, and that particular algorithm will help me to identify the clusters, and that's how I can segment my customers. Okay, so that becomes my unsupervised learning problem. I hope you understood the major difference between clustering versus classification. So classification is a supervised learning technique where you will have a output variable which you would like to predict. While clustering is an unsupervised learning where you do not have any kind of labels available or the output variable available in your data, and you use this clustering technique to identify or to detect the unique clusters in the data. Now, where all you use these clustering applications, multiple ways. These are the limit. These are very few examples in the retail and marketing. We identify the buying patterns of customers through this clustering. We recommend new books or movies to new customers. So you might have seen that, okay, even the recommendation system, and we will discuss about the recommendation system in more detail. Uh, for example, if you are very much similar uh, let's suppose you are very much similar to me, okay, and whatever books or movies uh, we read, those are very common. Okay, so you also like certain books, and I also like the same books. You also like whatever movies, I also like those movies. So what will happen is we will use this clustering technique, and we will find the unique clusters. And let's suppose if you and I, we both are in the same clusters, it will go and match how many of the books and the movies are common. Okay. If the similarity is very high, then whatever books I have read and you haven't read, those will be recommended to you. And whatever books you have read and I haven't read, those books will be recommended to me. Because our likes and are same, our interests are same. So there is a high chance that the books which you have read could be of my interest also, and I would also like this. So this is the kind of logic we will use for recommending, and you can relate it to our real life also, right? So if you have a very close friend and if he suggests something, okay, why don't you go and watch this movie, why don't you read this particular book, okay, I liked it a lot, so definitely there is a high chance that you will also like, or you will also go ahead and watch that movie or read that book, right? So in the banking fraud detection, so here uh, this is an interesting use case. So here the fraud detection, how it can be solved through clustering. So here there would be only two clusters in this particular data. One would be the normal transaction, a genuine transaction, and a fraudulent transactions. So here I will ask this algorithm to come up with only two clusters. So what it will do is it will try to find out the patterns. Okay, so if most of the transactions, those are quite similar, those are regular transactions, all those transactions will be grouped into one cluster. And the transactions which are quite different with this general transactions or the common transactions which are happening, so those will be segregated and those will be grouped in a separate cluster. Okay, now the banks can go and look into those transactions which are not normal, which don't look like a normal transaction, and then they can examine, and then they can inspect it, validate it, and then accordingly they will take the decision. Now these kind of fraudulent transactions may happen multiple times if you and in a very unique way every time. Now, you might be seeing that all these online frauds are happening in a quite in a very strange way, a very different way. Nowadays, you might have witnessed now. Yesterday only, I got a call. Uh, it was like somewhere from Mumbai, some cops called me, okay, and it was an automated call saying that, okay, there is a summon on you and you have to present in the court, something like that. It has come. And this I have heard that some of my friends also got the similar kind of a calls. I don't know how many of you have experienced this. So what these guys are doing, they are creating a fear, okay, in the people that okay, that that they have done something wrong and there is a case which is and the cops are behind them and all those things. They are creating that kind of a fear in them, and then they are taking the money. So first they will ask you to send certain amount of money, to initiate the case or something like that. Okay, to hire a lawyer or something like that, and like that they will keep on asking money. So this is a very different kind of a fraud which is happening. So in your historical data, you will not have this kind of uh, fraudulent data available. So when you use any supervised learning technique, probably these kind of frauds may miss out, and your model may not able to detect these kind of frauds, may not be able to predict these kind of frauds. So generally there we use this unsupervised learning technique. Unsupervised learning technique, what it will do is majority of the transactions would be a genuine transactions, right? So what it will do is whatever the transactions are happening, it will try to segregate between the normal and the uh, fraudulent transactions, or abnormal transactions. Okay, we call it as anomalies. So here the anomalies are not being classified into multiple categories. They will just look at the pattern, this algorithm, and it will try to see that okay, whether it is falling in a cluster, normal transaction cluster, or it is not falling. If it is not falling, all that transactions will be grouped under the anomalies. Okay, and now that's where the bank will go and look into the data and see that okay, whether it is really a fraudulent transaction or not. And that's how they will come up with they will identify all the unique kind of frauds or unique kind of transactions are happening. I'll give you an example. For example, if you are working in India and some transaction is happening somewhere in Indonesia or some other place, okay, and it could be a chance that you might have traveled to Indonesia, but if the same transaction has been happened, some transaction has been happened in India yesterday, and now some transaction is happening in Indonesia with that too of a higher amount, then it will immediately identify it as a some kind of anomaly. Okay, and then the bank will raise a request, and you will get a message or you will get a call saying that is that you who is making the transaction. If it is approved, then only they will make the transaction. So very useful and very important solution for the banks, to find out these frauds. Okay, again, identifying the clusters of customers. Again, I'll want to talk about a use case here related to a manufacturing domain. Here we have basically done this kind of clustering, build this clustering solution to find out the loyal customers or the most frequent buyers. Like that, we have identified 8 different clusters, okay, in the data. Uh, High spenders, highly loyal customers, and then most frequent buyers. So like that, we have identified 8 different clusters. And here we have just used 3 attributes. We have used, we call it as an RFM analysis, where R means recency, how active that customer is, okay, how recently he has bought or he has made any transaction. So that means he's active. Okay, he's still with the company and he's buying your products. So the recency is important. Then comes the frequency. How frequently he buys your products. Okay, so the most frequent buyers are always potential customers, right? and then the monetary. Even if the person is frequent buyers, but if he is buying a very small worth of products, then again it is not profitable, right? So we also look into the monetary. So let's suppose there is one customer who just buys once in uh, you know once in a year or once in half yearly, okay, but he buys in bulk, okay, he make big transactions. So those customers are could be important. So we just took these three, and and that you can easily calculate, right? Recency with the date of transactions, you can find out, the recency part, like how many days before, that person has made a purchase. So that many number of days you can calculate for every customer. So from current day, uh, since he made the last purchase, okay, so you just find out the difference. So that would be your recency. So the person who has bought 1 day before would be more recent when compared to a person who has bought 10 days before. Similarly, frequency. Frequency, I will take a particular duration, for example, 1 year or 6 months, and in that time period, fixed time period, I'll see that how many times the customer has made a purchase. A person making 20 different transaction in that limited time would be having a high frequency when compared to a person who has made only 2 or 3 transactions in that period, right? So the frequency would be less. So again, that I will calculate, and then finally the monetary. So if I'm taking a 6 months data or 1 year data, cumulatively I'll see that how much amount of revenue the business got generated, has generated from that particular customer. Or else I can take an average amount. Okay, in a month, what is the average amount of worth of products that person buys? So these are the three important parameters which can help you to find out the customer buying pattern, right? Now, I will use some statistical technique. For example, let's suppose I'll take quartiles, okay? And then I will take that recency column, frequency column, and then the monetary column, and then divide into multiple quartiles. The first quartile would be important for me, okay, for recency. The last quartile would be important for frequency, and for monetary also last quartile would be important. Which all customers are falling in each of those quartiles, I will score them. So for example, there are 4 quartiles. So the recency, if it is less, then that means that is good. The people who are in quartile one, okay, I will rank it as 4 being the highest, right? While the people who are in quartile 4, so that means their recency is very high. So I will score them less. So I'll score them as 1. Just like that opposite, I will do it for frequency and monitoring. So for one customer, if the score is, let's suppose 431, so total score would be 431. Another customer, let's suppose he has been scored high on all the 3 parameters, 444. So his score would be 444. So his score would be high. So this is very simple way of segmenting the customers. So I can now put a threshold saying that whoever has scored more than 420 or 430, let them mark them as a more potential customers because they are very high on frequency, recency, and the monitor, right? So similarly, the people who are at score of 111, so I can put them as a low potential kind of a customers. So this analysis is known as RFM analysis. With this, I can find out who all customers are loyal. Loyal means the people who are more frequently buyer. Okay, so whoever has scored 4 in the frequency, those people I can label them as a loyal customers because they are always, uh, buying, uh, products on a regular basis. Or else what I can do is I'll take these 3 variables, R, F, M, and I will use this clustering technique, which we are going to discuss in a bit now. and I will try to find out the unique clusters from the data. So that will be done automatically by that algorithm. You need not to do all that scoring and everything, for that. Similarly, for the insurance, again, the fraud is important for the claim analysis and for to identify which of the customers are risky customers and all. Okay, so clustering plays a very important role in terms of identifying a risk or identifying any kind of anomalies in the data. So why clustering? It can also help you in exploratory data analysis, in summary generation, in outlier detection, finding duplicates, and even in the pre-processing step. So pre-processing step I have discussed, like in the sampling, when you have to generate the sample at that time also you can use this clustering technique. Okay, so there are multiple different kinds of algorithm when it comes to clustering, and every algorithm works in a different way. So first kind of techniques are called as partition-based clustering, and these are relatively efficient because it is because this algorithm is easy and it uses a very simple logic. So that's the reason it is relatively efficient. It can run much faster than other algorithms. And in that, the most popular one is the k-means. Okay, so which we are going to discuss today. And then we have a hierarchical clustering. Hierarchical clustering is more about, it creates a hierarchy of data points. Okay, and just like you might have seen the hierarchy in the organization, right? We call as org structure. So CEO, this CFO or CXOs reports to CEO, and all these VPs reports to the CXOs, and all these managers reports to these VPs, right? So like that, you will find the org structure in every company. So the same kind of logic here we will use in hierarchical clustering, and in that agglomerative clustering is the most popular one. So it also produces a tree kind of a structure, and what how it works is it works from the bottom to top. So it will take the data points and it will identify which of the data points are similar. Then those data points will be grouped together. Then again, it will go to the next level and it will understand which of the data points are unique or are similar to other groups, and then it will group those data points to that particular group. So like step by step, it will keep grouping the observations into multiple groups. Now, finally, we will have a density-based clustering. So there are certain shortcomings, in these two algorithms, which we will discuss. And now this density-based clustering addresses those shortcomings. Okay, and in that, DB-scan is a very popular clustering technique. So we will cover all these three different types of clustering in detail. Okay, so let's start with the k-means clustering. So before getting into this algorithm, anybody has any questions so far?
No, sir.
All right. Okay. So k-means clustering. So again, the same use case we are going to discuss, and the same thing, we will do it in Python as well. So here, how does this particular algorithm works is, so firstly, it is a partitioning clustering. So basically, it works from top to bottom. You have the entire data, and in the entire data, it will try to identify the clusters. Okay. Second. Okay. So partition. So here, this K means we all know, right? Means is nothing but the uh, average, right? So means in statistics means average, and k is the constant, is a value, okay, which we have to give it to this particular algorithm, just like KNN, right? In KNN, the k we need to specify, right? So here also in k means, this k number, and this k is nothing but the number of clusters. The number of clusters we need to specify to this particular algorithm. So whatever number of clusters we will specify, that many division it will do on the data. Okay, so this k-means algorithm will divide the data into non-overlapping subsets, which is nothing but the cluster. So all these clusters would be non-overlap. So you will not find a cluster something like this. Okay. So in this, if this is a kind of a cluster, you will get it. So the observation, let's suppose if it is falling here, you cannot able to label those those observations because it would be difficult whether to label it to either this or that, right? So examples within the clusters here would be similar, and examples or the data points across different clusters are very different. So that homogeneous and heterogeneous um, thing would play here in this particular algorithm. It will try to find out all homogeneous data points, and then it will group them into one cluster. And the data points which are quite different, then those will be grouped under different clusters. Now, how it is done? So if you have to do it manually, let's suppose how you will do it. Now, let's suppose you have these different colored objects like blue, red, and orange. Now you have to create a cluster. Now what you will do, you will find out one attribute, the color, right? And you will segregate because the color are similar. So all the blue ones you will categorize or cluster them into one group. All the red ones you will do it in another group, and the orange one into a separate cluster. So here you have picked up one attribute, okay, of that object, which is color, and accordingly you are clustering them into different groups. Now, what if you have 20 different attributes of an object? Let's suppose shape, size, and a lot of other things, right? Then it would be difficult for you to manually come up with a unique clusters. Okay, so in that case, this k-means algorithm, will work effectively in terms of identifying those clusters. How it does is, it again uses the same technique or same method, mathematical method, which we have used in KNN. In KNN, what we have done, we have identified the nearest neighbors, right? And how we have identified the nearest neighbors? By finding out the distance between those observations. So here also we will do the same thing. We will take the input features. Input features are nothing but the attributes of those objects. And we will find out the distance between the data points. If the distance is high, so that means those are different. They are not similar. If the distance is less, so that means they are kind of lying very close, in the n-dimensional space. That's the reason their distance is less. In that case, those observations will be considered as a similar observations. So based on this similarity, so this is one point. Let's suppose x5 is one of the data point, x6 is another data point. So we'll find out the similarity score for these two data points. The similarity score is nothing but, first we will find out the distance, and the inverse of that distance will become the similarity. Okay, so that is your similarity. Now every observation with the other observations, the similarity will be calculated, and then accordingly it will be grouped. So now if your data is pretty large, okay, then it's going to be a very expensive task, right? It will take a lot of time, and it will requires a lot of compute, to calculate all those similarity score, for every pair of data points. So for that, what uh, thing is done is, okay, so this, I think you all know that how the distance is calculated. So again, here also we use Euclidean distance. And you didn't know about this particular formula, right? So I'm not going to repeat it. So with this Euclidean distance, we'll find out the distance, and once the distance is calculated, the inverse of distance will give me the similarity. Okay, so for example, now data is scattered in the n-dimensional space, and you have two observations in this n-dimensional space, something like this, where their attribute of age and income is given these values. So now, based on these values, I can able to find out the distance. Okay, so here every pair of the data points, the distance will be calculated, and it will see that, okay, one observation is closest to what all observations, right? And those observations will be grouped together. And here we have also specified k, right? For example, k equal to 3. Now the algorithm will take care, it will understand based on the k value that how many clusters it needs to um, identify, and then accordingly it will map those data points accordingly in those number of clusters. Now, as I mentioned, if it is done in that way, it is going to be too expensive in terms of time and in terms of compute. So here this algorithm uses a little bit different approach, to come up with these kind of a clusters. Now, what it does is, let's suppose I have initializes k equal to 3. So what it will do is, first it will randomly assign 3 different points in the n-dimensional space. Randomly. There is no fixed position for these points. It will randomly, it can be placed anywhere, okay, in the n-dimensional space. Now these points are called as centroid. I'll explain you what centroid is. So basically, now you can just think about centroid is the central position of a cluster. So if these are your clusters, now the center point of the cluster is known as centroid. So these are the centroids. Okay, so initially, as the algorithm does not know anything about the clusters, it will randomly assign these 3 points based on the k value what we have specified. Let's suppose the centroid random location of these centroids are these. Okay, now what it will do is, instead of finding out the similarity between every pair of observation, now here in this case, what will happen is every observation will be mapped with these 3 points only. So every observation distance will be calculated with these 3 points, with C1, C2, C3. Similarly, as I've calculated the distance of this particular observation with C1, C2, C3, similarly for every rest of the observations, the distance will be calculated with respect to C1, C2, and C3. Now, let's suppose I've taken this observation. Now, what it is showing? This observation looks like it is closer to C1 when compared to C2 and C3. Now, what will happen is, in the first iteration, this particular observation will be mapped to this particular centroid. Okay, so let's suppose this particular cluster. Okay, so it will be mapped to cluster number 1, right? And this particular observation looks like it is close to C2. Then now this will be mapped to cluster 2. This will be mapped to cluster 2. This will be mapped to cluster 3, right? Based on the distance. Now, once it is done, okay, so like that, okay, it will find out the points. Now, once it is done, now what will do is, now all your data will be mapped to these individual clusters, right? For example, based on the distance, these 4 points have been grouped to this particular cluster. These 2 points have been grouped to this particular cluster, and rest of the observation seems to be closer to this particular point. So they have been grouped to this particular cluster. So this is cluster 1, 2, and 3. But these clusters does not look like good clusters, because I don't think these are pretty homogeneous clusters. Okay, so what it does is, in the second iteration is, now let's suppose these are the observations which have been grouped into one cluster. These are the observations which are grouped in another cluster, and these are the observations which are grouped in the third cluster. Now, real centroids will be calculated for these clusters. How the centroids would be calculated? For example, now these are the 2 points, right? For this, it is x1, y1 is the coordinate. For this, let's suppose x2, y2 is the coordinate. The centroid is nothing but the average of the coordinates. So I have to, if let's suppose I have to find out the centroid of this cluster, let's suppose this is the cluster centroid of this particular cluster, the location would be x1 plus x2 by 2, y1 plus y2 by 2. Okay, so this would be the location of this particular centroid. Now for all these clusters, now the real centroids would be calculated. So now this new centroids would be identified. Now there would be a shift in the centroid. Initially it was here, which was randomly assigned. Now it will move to the original centroid, okay, of this particular groups. Now this would move here. Now this particular point will move a little bit on the left hand side. Now those are the real centroid. Now, if the centroid locations are moving, then again the mapping needs to be done, right? Because earlier these data points have been mapped to these particular locations of the centroids. But now the centroids have been shifted. Now, if the centroids are shifted, again the mapping of the data points needs to be done, right? So what will happen is now again the mapping will be done. So here the mapping is done, and one second. Okay, so we have computed the new centroids of each cluster. Now the mapping will be done. Now again, what will happen is now these particular yellow points, which was earlier grouped to this particular cluster, now there is a high chance that it will group to this particular cluster now. Okay. Now like this, again the points will shift from one cluster to another cluster. Initially, these yellow ones were part of cluster number 3. Now it will be part of cluster number 1, right? Now, like that, again, the reshuffling of the data points will be done. Again, the reshuffling of the data point, once it is done, then again the centroids would change. Because earlier the centroids was calculated based on these 5 points and these 2 points. But now the more data points have been added to this particular centroid, right? So this particular cluster. Now again, the centroid location would change. Again, if the centroid location change, again the mapping would change, right? The data points. So this particular process will repeat until there are no more changes. So after a while, what will happen is the centroid will become steady. After that, the centroid would not change. Once the centroid is not shifting, is not changing, now whatever data point has been mapped to those particular centroid will be considered as that particular cluster. So now here in this case, now this will become one cluster, this will become another cluster, and this will become another cluster. Okay, so like this. Though here it is looking like an overlap, but it is not an overlap. Okay, so it will find the non-overlap clusters only. So this is the whole process of k-means. It first randomly it will place k centroid, whatever number of k you will specify, that many centroids it will place randomly, one for each cluster. Then it will calculate the distance of each point from each centroid. And then the mapping or the assignment of each data point to the closest centroid is done. Once it is done, then again it will find out the real centroids of those clusters. And once the real centroids are calculated, again the mapping or again the assignment of the data points will be done, to those centroids. And this whole process will repeat from 2 to 4 until the centroids no longer move, until the centroids becomes steady, okay, will become static. So that's where the algorithm will converge, and whatever where it will stop, that kind of assignment, it will take it as a final assignment, and you will get the labels to those observations accordingly with those clusters. Now, with this process, we can assign the clusters to each of the observations, right? But how can we test the accuracy? In supervised learning, it was easy because there was an actual values available, right? And actual minus predictions will give us some kind of an error indication about the error, and we can understand how good your model is, right, based on those errors. But here we do not have any output variable available, right? We do not have any actual values available. We don't know, whether these clusters, what have been identified by these algorithms, are really correct or not, right? So that's the major disadvantage with this particular unsupervised learning. So how we can check the accuracy is, one is like external approach where we compare the clusters with the ground truth. So how, if it is available, if somebody has manually kind of in the process, if somebody has manually kind of labeling it and segmenting the observations, then you can go and test with that whether my algorithm has been properly categorized or properly identified the groups or not, right? If the ground truth is available, if there is any manual uh, process in place which is kind of labeling the data, then you can compare with that. The internal approach is this is a technical approach. You will try to find out the distance, average distance between the data points within the cluster. If you see that all the data points within the clusters are quite close, if the distance is very low, very less between those data points, then you can consider those as a good cluster, because within the cluster, the observations are tightly packed and they are very near to each other. So that means your cluster is looking like a good cluster. And again, between the clusters also you have to check. You have to check whether the observations between the clusters are far from each other or not. If they are far, then that means those clusters are quite heterogeneous and they are uh, quite dissimilar in nature. Okay, now here you might have seen that first step itself is about randomly placing the k centroid. But how this k centroid can we decide, right? So we took three in this particular use case, and we went with three random centroids. But who will decide whether we should go with three or four or five? Okay, how many unique clusters we will get in the data? How we will know, before running the algorithms? Before running the algorithm, it's quite difficult. So either you can check with the business, you should have a domain understanding, you should be in the process uh, to understand, how many unique clusters could be possible within the data, and then you can go with that particular k value. That's one way. Or else technically what you can do is you can use multiple k values and see that which k value is giving you a better result. So that is more of a technical way of identifying the k value. So here, what I've done is uh, here I've considered the mean distance of the data points to cluster centroid. So all the data points are there inside the cluster, and we have a centroid. And you know what is centroid? Centroid is nothing but the average of the coordinates of all the observations within the cluster, right? Now let's suppose this is my centroid. I will find out the distance of every observation with the centroid, and then I will take the average of it. Okay. So here I will find out the mean distance of the data points to the cluster centroid for all the clusters, and that sum would be my y column, right? Let's suppose if I'm taking k equal to 1. K equal to 1 means I'm not dividing my data at all. It's my original data all together, okay? And I will find out the centroid of that big one single cluster, and then I will find out what is the mean. Definitely it would be large, right? If you consider all these data points as one single cluster, okay, so definitely the distance of these data points with this particular centroid would be large, right? Now let's suppose if I am going with k equal to 2 instead of 3, let's suppose I am going with 2 clusters only. For example, this is one cluster and this is another cluster. So here the centroid would be somewhere here, right? So here again the distance, it would be lesser than the one single cluster. Definitely the distance will be will gradually will go down, okay, as you keep breaking your data into multiple clusters. But the point at which after which there is a very minimal improvement or very minimal decrease in the mean distance, we'll take that particular point. So this particular point is called as an elbow point. So in the interview, people may ask like how you will choose the k value in k-means algorithm. Then you have to say that elbow method. Elbow method is nothing but where you will iterate this particular algorithm at different k values and see that after which k value, if there is a minimal improvement in the mean distance of data points to the cluster centroid, that particular point I will consider as the final k value. See, at k equal to 1, there was a very high distance. At k equal to 2, there is a significant decrease in the overall distance, right? At k equal to 3, again, there is a significant difference. Again, at 4, again, there is a gradual decrease in the overall distance. 5, yes. But after 5, at k equal to 6, there is a very small improvement. So that means if I have a 5 clusters which are kind of very uniquely placed, something like this, these clusters. If I am going with 6, so what I'm doing is I'm breaking one of the clusters into 2 parts, something like this. Now here, the distance, by breaking this particular cluster, I'm not getting much improvement in the overall distance. Okay, so here that means all the observations in the previous cluster, okay, was was very close to each other. That's the reason after breaking that cluster, again I'm getting the clusters which are very near to each other. They are not too far. So that's the reason the overall distance between the data points with the clusters are not much decreasing, okay, when I'm going from k equal to 5 to k equal to 6. So now this would be your optimal k value, which you have to consider for for identifying the clusters. So this is the approach, the elbow method, which you will use, for choosing the k. Now, as I mentioned, this is relatively efficient, and this particular algorithm can be used for medium to large size data, and it produces a spear-like clusters. So this is something you remember it, because this is one of the shortcomings with this particular algorithm. It can only identify the spherical clusters, okay, or circular clusters. In some of the scenarios, you may not see a circular clusters. It could be in some other form also, right? So that's something, okay, we'll see that how we can address those kind of challenges with a more sophisticated algorithm called as DBSCAN, right? So it produces a sphere-like clusters, and it requires a number of clusters to initiate this particular algorithm. So as it requires in the beginning only, so what we will do is we will assign the cluster number, okay, and we will come up with the clusters. We go and calculate the distance uh, within the cluster, and then I will again use a different k value. Then again I will find out the distance. So like that, I will iterate it for multiple different k values, and then I will plot this particular graph, and then from this graph I will identify the elbow point, and that would be my optimal k value, which I need to consider to identify the unique number of clusters in my data. Is this clear, guys? Everyone?
Yes, sir.
Quite simple, but very effective. So we use this algorithm for different purposes, right? So you should know how to transform your data so that you can fit this particular algorithm. We have used it for even uh, for text and even for images. So firstly, what we have done is we converted the text data into a numerical data, and then we ran this particular k-means algorithm. So what we get out of this algorithm is we can able to categorize multiple documents into different categories. So here the problem was the customer was having different kinds of documents, soft copies, right, sitting there in one of the folder. So they were having millions of documents like that. Okay, so they were just taking scans and they were putting that into particular folders. So there was invoices, there was policy documents, there were manuals like that. They were having different kinds of documents sitting in that particular folder. The major problem asked was requirement was to extract the information from those documents, the important information from those documents, and then putting that into a database. But we cannot use one single technique on all the different formats of documents, to extract the meaningful information. So firstly, we had to categorize those documents. So all the invoices, let's suppose if it falling in one category, then we know that what kind of information needs to be retrieved from those invoices. If it is the policy documents, what kind of information needs to be retrieved from policy documents? We need to identify. So first, categorization was important. And as they haven't done anything, before, and all those documents were just sitting in a one file repository. So the first task was to categorize them. So what we have done is we have just extracted entire text. We did the cleaning part. We just extracted some keywords out of each of the documents and then created one structured data. Okay, so where the keywords would be the columns and the documents would be the rows. And if that keyword is existing in that particular document, then it will be labeled as 1, otherwise it will be marked as 0. So like that, we have converted that entire text data into a structured data. And after that, we ran this k-means algorithm. So this k-means algorithm, what it did is, in whichever documents uh, certain keywords are existing, it has grouped those particular documents into one cluster. So like that, we could able to identify the unique clusters. Once the unique clusters have been identified, then we name those clusters saying that it is these cluster is all about invoices, these cluster is all about manuals, and like that. Okay, we categorize. And then each category we dealt it separately to extract all the important information from those documents. So this is how we have used it for text. In the images also in the similar way. Okay, what we have done is uh, you might have heard about OCR technique, optical character recognition. So here, when we were extracting the data from these scanned reports, so we have to deal those reports as an image, right? And in the images, the formats were different. So there were different kinds of tables, okay, in the scanned documents, and we have to identify in a table whatever text is written, whether it is falling inside one box or whether it is uh, kind of overlapping to multiple boxes, right? So, for example, the header is like throughout the table, right? So there we have used k-means. So here we have taken the pixel values, and based on the pixel values, we were identifying which of the basically the cells are near to each other. So to find out, so for example, there is in one cell it was written as name, customer name, and then in the following box there was a real name. For example, Tata Consulting Services, right? So customer name is in one box, it is written, and in another box, the actual name of the customer was written. Now we have to map the custom, because in some of the documents, what was happening, the customer name was on the top, and in the bottom, the Tata Consulting Services, like, or the real name of the customer was written. So the mapping was becoming very difficult. So what we have used the k-means to map which of the text are nearest to that particular label, and then accordingly we try to map those labels, those values. So it was a quite challenging, that particular task, because different formats we have to deal, and then again, from different formats we have to extract the information. So there again, we have used this k-means, and it helped us in dealing to some extent, not 100%, but uh, significant level of improvement we could able to achieve by using this particular algorithm. Okay, so there are several use cases where you can use this k-means, as I mentioned, to find out the anomalies. Anomalies is very much important in every business, right? If even, let's suppose, in the production, if the machines are running, and if on the fly you have to identify if there are any anomalies in any machine. Anomalies means if the temperature is altogether is changing. So one way is like condition monitoring, where you can put a threshold saying that if the temperature is increases above 50 degrees Celsius, then you should get an alert. That's one way. That's known as condition monitoring. Here you need not to build any logic, nothing, a simple logic. You have to just put greater than 50. If the temperature goes beyond 50, then you will get an alert. So like that, you can put the alerts on every column. But sometimes what will happen is there would be some kind of a pattern. All the variables could be under the threshold, but it may lead to a failure. So, and to find out those kind of scenarios could be difficult. If the temperature is also under control, okay, under 50, the voltage is also under threshold, but that kind of scenario should not happen. Okay, let's suppose one unique pattern that should not happen. Let's suppose there is a vibration also, there is a voltage which is um, kind of very close to the threshold, the temperature is going low. That could also one of the pattern which may lead to a failure. And this kind of pattern probably might have not seen, okay, in the during the running condition. It is a very unique pattern which might have come up, at one particular time. So this clustering technique, what it will do is it will identify those observations clearly. It will not say that whether it is a failure or not, but it will say that, okay, it is altogether a abnormal behavior. This kind of a behavior has not been seen in the previous data set. Okay, it is altogether unique. Now the managers or the operating managers or whoever is taking control of those machines, they will look into those particular patterns. Okay, so if they classify it as really, if this is a very abnormal pattern and it may lead to a failure, now they can go and they can rectify those issues. Otherwise, they will map it to, if it is like normal behavior, they will map it as normal. So like that, in future, if any such patterns may come, that will be mapped under that particular category as a normal category. So, so like that, you can use this clustering technique for multiple purposes for solving different kinds of problems. Okay, so I'll stop it here. Tomorrow we'll see the same use case where we will take this customer data and we'll try to segment those customers with the help of this k-means algorithm. So I'll pause here. Let me know if anybody has any questions or anything they would like to discuss. Okay, so if there's no questions, then we'll wrap up the session today. Let's connect tomorrow. Thank you, guys. Have a nice day.
Thank you.
Bye.